Hello, I'm Tahir Morali, and it's my pleasure to introduce you to IRIS, the International Space University's educational experiment on the International Space Station. Let's kick it off with a message from Canadian astronaut Bob Thirsk.
Space Station. Supported by hundreds of fellow Canadians on the ground, I will, over the next few months, carry out life and physical science experiments designed exclusively for a weightless environment. I'll be remotely operating Avatar, a robot in the CSA's Martian simulated terrain, in preparation for future orbit-based exploration activities. And I will be the subject for the IRIS education experiment, designed by students of the International Space University. This experiment will determine the impact of weightlessness on human perception of optical illusions.
As Dr. Thirsk mentioned, these illusions are ambiguous figures that have two different representations depending on the cues our brain gives us. Here, try these flight software samples and see if you can distinguish each image represented on the right. Your brain uses gravity as one of those cues to determine your orientation so that you can see each precept or image. So how does your body react in 0G? Well, that's what IRIS is going to test. Now, IRIS is special in that it is the first experiment entirely designed and analyzed by students on the International Space Station. So, we are also responsible for collecting data and educating the community. IRIS is an international affair. Complementing Dr. Thirsk's vision are the efforts of 16 ISU students from 9 different nations and significant contributions of the Canadian Space Agency, NASA, and Centre National de Recherche Scientifique. To compare IRIS data from orbit, our team was invited to collect data on a parabolic flight.
Okay, my name is Gilles Clement.
Angie Buckley.
I'm Tahir Morali.
Sunny Chloe. Don Lim. Diego Arvina.
Flights for the 50th parabolic flight campaign of ESA in Bordeaux, France. We're flying the IRIS experiment.
In 1G, enter 1. You tell us when you're done. Okay. Everybody is a tail. So we'll do years when it comes back.
Yeah, give him a few seconds because it's actually 47 degrees. The injection do fly free. It's a real problem. Real problem. At 42 degrees now down, you have the recovery point. It's very symmetric. This one works. This one works.
Now, the setup on the International Space Station is the same as you see here, with the subject wearing a heads-up display and holding a trackball mouse to indicate when they see each image flip. Data was also collected during the 2G portion of flight.
Michael, you made it.
The operator would indicate when we were in certain portions of flight. As you can see here from our data analysis, there is a significant lag time in the reversal rate during the 0G portion of flight. IRIS kicked off at SSP-08 in Barcelona, and will continue with you at NASA Ames. This has already included a live Q&A with the Expedition 20 crew, the allocation of IRIS on the crew schedule, and the live operations during the first in-flight session. Welcome to the IRIS MDA. Are you ready to IRIS?